Hello everyone. So students, you have to pay attention to what I have to explain to you. Today we are taking a look at the qualitative analysis for this year's WAEC SSC 2026. So don't forget that there are two substances that are involved in this year's qualitative analysis practical. We have lead carbonate and starch. Lead carbonate and starch. Now, this is how the question may likely be set. The first thing you have to note is that the two substances will be mixed together, and the mixture will be called C. It can either be C or CN, whatever. But the mixture of the two substances we are testing will be called C. Now, if you are told to add distilled water, the first question you are likely going to be asked is for you to add distilled water and then filter. You add distilled water and filter. Then you filter it. This will be your observation. The mixture is going to be insoluble in water, and your inference then will be C is insoluble, or you say C is an insoluble mixture. Then question 2, the residue plus iodine solution. Once you are asked to look for use iodine solution is meant to test for starch. And the observation you are going to write is blue-black coloration. The inference is residue contains starch, because starch is not the only component of the mixture. It's one of the components. So you are going to write blue-black coloration, residue contains starch as inference. So whenever you are told to use iodine solution, just know it's starch they are trying to test for. So write your observation and the correct inference, and you get a full mark for that. Then for number 3 and number 4, aqueous sodium hydroxide and aqueous ammonia, they are usually used for testing for cations. Cations like zinc, lead, aluminium, copper, 2 ion, ion 3 ion, and ion 2 ion. But for this year, the cation we are going to test for is lead. Now, very likely, they will start off with sodium hydroxide, but it's not compulsory they start off with sodium hydroxide. They can just go direct to aqueous using aqueous ammonia. But just in case you are asked to add aqueous sodium hydroxide, I beg your pardon, to the residue in drops, then this will be your observation. White precipitate is formed. Then your inference or conclusion will be zinc, aluminium, or lead 2 ion present. Then that is in drops. Then in excess, the white precipitate is going to dissolve in excess of the aqueous sodium hydroxide. So in drops, the white precipitate is formed. In excess, the white precipitate dissolves. It becomes soluble in excess sodium hydroxide. When that happens, it means your inference will be the same as when it's in drop. You have zinc, aluminium, or lead 2 ion present, because you can't categorically say that since the precipitate dissolves, then lead is present. There are other cations that can dissolve in excess sodium hydroxide apart from lead. The other ones are zinc and aluminium. So this is not a confirmatory test for lead. So you are going to write the same thing that we wrote before for drops. That is for sodium hydroxide. The inference is the same for both in drops and in excess. Then let's go to sodium aqueous ammonia. If aqueous ammonia is added to the residue, The residue is what is left in the filter paper after filtration. Now, if sodium hydroxide, a portion of the residue is added to aqueous ammonia. Aqueous ammonia is added to the residue in drops. You are still going to have white precipitate formed, as in when sodium hydroxide is added in drops. So you are still going to write the same conclusion, the same inference: zinc, aluminium, or lead present. Then, in excess, the white precipitate this time around will be insoluble in excess aqueous ammonia. Then, in this case, there are only two cations that can be insoluble in excess aqueous ammonia. They are aluminium and lead. Don't forget, only two cations form white precipitates that is usually insoluble in excess aqueous ammonia. So they are aluminium and lead. So at this point, there is no more zinc. Zinc has left. If you look at the inference from number 3I and II to number 4II, you see that the inference is the same for the three of them, because zinc, aluminium, and lead, they give similar results. But this time around, in excess aqueous ammonia, aluminium and lead will be left in the inference. Zinc is no longer there. Now, how do we distinguish between aluminium and lead? How do we find out the exact cation? Is it aluminium or lead? Then very likely, then you are going to have a confirmatory test for lead. One confirmatory test for lead is the residue plus HCl. A white precipitate to be formed which is insoluble in excess. That's a confirmatory test for lead. It's only lead that gives that result. So you are going to have lead 2 ion present at this point. At this point, aluminium is no longer there. Lead has been confirmed. But in place of HCl, you can still be asked to add drops and excess aqueous tetrahydrosulfate 6 acid, that is H2SO4. H2SO4 can be used in place of HCl. It will also give the same result and you have the same inference. Don't forget, only lead 2 ion can give a white precipitate which is insoluble in excess HCl or H2SO4. Then, if you are asked to add HCl or H2SO4 to the residue and pass the gas that is produced through lime water, that means you have residue plus HCl plus lime water. Whenever lime water is used in chemistry or even biology, the lime water is meant to test for just one gas, carbon dioxide. So once they are asked to use lime water, then they are trying to confirm if the gas is carbon dioxide. Of course, the gas for this here is going to be carbon dioxide. So your inference is going to be effervescence due to the release or evolution of a colorless and odorless gas which turns lime water milky. This will be your conclusion. Or you can as well say effervescence due to the release of a colorless and odorless acidic gas. That means if you are asked to use litmus paper, if you are asked to use moist litmus paper, at this point, don't forget, if it's lime water you are using, then you can't say the gas is acidic. You simply say the gas is colorless gas which turns lime water milky, and your conclusion is going to be the gas is carbon dioxide from triazocarbonate 4 of hydrogen triazocarbonate 4 ion. But in place of lime water, if you are asked to use moist litmus paper, that means they want to find out if the gas is acidic, neutral, or basic to litmus. Now, if you have to use litmus paper, that means you can add to the adjectives here, the list of adjectives here. We have colorless, we have odorless. You can also add acidic to it. You can say an acidic gas, which turns lime water milky. But if you are not going to use litmus paper, then you may not add the word acidic. But certainly, camphor oxide is an acidic gas. They're the only acidic gas that turns lime water milky. So all you have to do is to study this table so that you know the right observation to write and the right inference. Don't forget, whenever you have to use iodine, you are simply testing for starch. So you don't have to bother yourself. You write your blue-black coloration as observation, and you write residue is starch. If you are asked to use sodium hydroxide and aqueous ammonia, you are definitely going to test for one of the cations. But this year, the cation that we are testing for is lead. So that is that for this section. So we'll now go on to take some other calculations involving the volumetric analysis for this year's WAEC 2026 chemistry practical.